All right, number 6, we have 3 parts. We're given the function f of x as x goes to 2 is equal to 6, and we want to find each value for epsilon. We want to find the corresponding value of delta. So again, if we use our graph, we're given that the absolute value of x minus 6 is going to be less than epsilon, and for part A, we want epsilon to be 2. So again, with inequality, we're staying within 2 from the value of 6, so that means we will go plus 6 and, plus 2 and minus 2 from the 6. And so using our graph, if we go plus 2 on the y-axis, that lands at 8, and we find out where that corresponds to on the x-axis, and that gives us a coordinate of 8. And then if I go back to 6 and then I go down 2 and find out the corresponding value, we get a 1. So we're going to be using these values to compare and find corresponding delta values for the expression x minus 2 is going to be less than delta. So if we plug in a 1 and we say, okay, absolute value of 1 minus 2 gives us a negative 1, and we turn it positive, we get a 1. If we do the same thing, absolute value of 8, plugging in each of these values for x, we get 6. So in the previous example, both of these numbers were the same. Now they're different. So in the text it talked about you want to make a symmetric interval. If I was to use 6 and use an interval that went 6 around the x value of 2, one side would be encased, but the other side would be too much. However, if I use 1, it would satisfy both sides. So there's a lot more room on one side, but it would satisfy both. So in this case, we would want to use the smaller of the positive values for delta in order to satisfy when epsilon is less than 2 on the y. That being the case, we want to write an inequality. So kind of using the method that it has to be between 0. We're just using this inequality here. That 0 is going to be less than delta, and then delta is going to be less than 1. 0 less than delta, and we're going to put less than or equal to because it can be equal to 1 on the upper end. So less than or equal to 1. All right, part B, it's going to be similar. We're going to do something similar to part 1. This time epsilon is 1. So again, using 6 as our limit, we're going to go up 1, trace it to the graph, and find the corresponding x. And so that will give me 7. And then if I go to 6 and go down 1, looks like we hit at 1.5. Okay, so again, if I find the limits of these, I'm going to get 0.5. If I do 7, I get a whole 5. Again, we want to use the smaller of the 2, and we want to set up an inequality that lets us know what delta should be. Delta would be 0 less than delta, which will be less than or equal to, since we're condensing the right side and we can use all the numbers up to 7. We can certainly use the 0.5 on the other side. All right, then here we want to make a conjecture about the values of delta, and then we're going to write an inequality. So if we compare these, we had 2 epsilon values, and we found 2 delta values. epsilon was given to be 2 and 1, and then the corresponding delta that resulted from part 1 was 1, corresponding delta in part 2 was 0.5. If we look at the relationship epsilon and delta, epsilon is twice what delta is, or we can say delta is 1/2. And so I believe we write the inequality that 0 is less than delta, and delta will be less than or equal to 1/2 of epsilon, because each time is half of that. So we'll say 1/2 of epsilon.